This video is going to look at determining concentration of a solution. So let's just discuss what the definition of concentration is. It's a measure of how much solute you have dissolved in a certain amount of solvent. When we talk about a solution being concentrated, that means that we have a large amount of solute. And then we could talk about a solution being dilute, meaning it only has a small amount of solute. So let's say you were making iced tea. If the iced tea is really, really dark, meaning you have a lot of sugar, a lot of solute dissolved in your water, we would say it's a concentrated solution. If you only have a little bit of sugar dissolved and it's kind of watery, because there's only a small amount of solute, we would call that a dilute solution of iced tea. We have different ways of expressing how concentrated a solution is. So in Regents chemistry, we'll talk about molarity, which is represented with a capital M. You could look at the unit for molarity on table D. Parts percent by mass, percent by volume, and parts per million, which gets a little unit of ppm. Again, the units are represented on your units chart on table D. If you ever forget, what are the units that go after it? If you flip to table T on the back of your reference table, you'll see that we have some equations that we're going to be using for this chapter. So we have percent composition. We've looked at that earlier in the year. Percent by mass, part over whole times 100. It's going to come up again in this chapter. Parts per million, grams of solute over grams of solution times a million. And molarity is moles of solute over liters of solution. So we're going to start with molarity today. Molarity, we just said the definition is moles of solute per liters of solution. So your units would be moles, MOLs, over liters, or moles per liter, which we represent with a new unit as just capital M. So like I mentioned before, table D will show you, if you forgot, the unit for molarity is capital M. You could write it as moles per liter, but it's simpler just to write a capital M. So let's jump into an example. What is the molarity of a solution that contains 4 moles of NaOH on 0.5 liters of solution? So we know that our equation for molarity is molarity equals moles over liters. So we're just going to take the information we have in our problem. We have 4 moles. And we have 0.5 liters. And you would just plug that right into your calculator. And you would get that you have a molarity of 8. When we write molarity, like I said, we mentioned that we're going to write a capital M. So you'll see 8.0 M would be your final answer. Another equation we're going to be looking at in this chapter has to do with finding the molarity of a solution. When you're given 2 molarities or we're given 2 volumes, finding the alternate molarity. This is the dilution equation. It's going to be on your reference table under titration. You'll see it as MAVA equals MBBB, or I'm just writing here M1V1 equals M2V2, same idea. So here our setup would be, we have 100 milliliters of a 1 molar solution. So our first molarity is 1.0 M. Our volume is 100 milliliters. We want to know what will be the concentration, which we're going to represent as a molarity, of the resulting solution. And they tell us that the second volume is 25 milliliters. So we have M2 times 25. And we just solve for X just like you do in math. And you would get that X is equal to 4. And capital M, because molarity is represented with unit of M, moles per liter. We're going to look a lot more at this dilution equation when we get to acids and bases. But I just figured we could show you it now because it does introduce the idea of molarity into an equation. You will use this when we're looking at trying to find a second concentration, or we're given, if you look, 2 volumes in this equation. So in the molarity equation, there's only a spot for 1 volume value, but here we're given 2 volumes, so we're going to use the dilution equation. Another equation we're going to be looking at is percent by mass. We've already looked at this before. Here we might be talking about trying to figure out what's the percent by mass within a solution. So the same idea that we've seen before. What's the percent by mass of sodium hydroxide and 2.5 grams are added to 50 grams of water. So the only difference here is that when we talk about percent by mass, we say part over whole. Remember that a solution contains a solute and the solvent, so we're going to add the solute to the solvent to get the whole. So here your setup would be the mass of the part. Well, the part is the smaller amount, the 2.5 grams, divided by the whole thing would be the 2.5 grams plus the 50 grams. So we have 52.5 grams, and then you multiply by 100, and you get 47.6%. Next, we introduce this idea of percent volume. It's the same idea like percent mass, part over whole times 100. In this question, they want to know what's the percent by volume of alcohol if I have 50 milliliters of ethanol diluted with water to form a total volume of 300 milliliters. So same idea, part over whole times 100. Here we're going to do 50 over 300 times 100. Why do we use 300 and not 350? Is because in this question they tell you the total volume is 300. So if in a question they tell you the total volume, that's going to go on the bottom. Or if they told you the total mass, that would go on the bottom. But if they're giving you the pieces, the solute and the solvent, that's where we're going to have to add them together. The last equation we're going to look at to determine the concentration of a solution is parts per million. And the equation coming right off the back of the reference table is grams of solute over grams of solution times a million. So here's an example. Barium sulfate solubility at 50 degrees Celsius is 0.00034 grams in 100 grams of water. Express this solubility in parts per million. So your solute is the one present in the smaller amount. So we have 0.00034 divided by the grams of solution. Well, the solution is the solute and the solvent. So 100 grams of water plus the 0.00034. And then we're going to times it by a million. And plug that into your calculator. You should get 3.4, and the unit for parts per million we're going to represent as ppm.